Welcome to our today's class. It's on an experiment to determine the percentage of air used by burning copper metal. Procedure. 2 syringes are used as shown in the diagram below. Syringe A is filled with air and initial volume of air in the syringe noted, while syringe B is empty. Air is passed over heated copper turnings repeatedly until there is no further change in volume. The apparatus are then allowed to cool and the final volume is noted. So you can see the apparatus as described above. We have syringe A and syringe B. In between there is a combustion tube which is fixed to them, and copper turnings have been poured into the combustion tube. Now we have loosely packed glass wool on both sides of the combustion tube to prevent the copper turnings from being blown into the syringe. Now, what are the observations from this? Now, it is observed that the volume of air in syringe A decreases. Then something else that is observed is that brown copper metal changes to black due to the reaction with oxygen to form black copper 2 oxide. The chemical equation for the reaction: copper plus oxygen gas to give us copper 2 oxide. Now, it's important to note that the color of copper is brown and the color of copper 2 oxide is black. So that is one of the observations, because copper combines with oxygen to form copper 2 oxide, which is black in color. The calculation of the percentage of air used by burning copper metal. So the formula we are going to use is initial volume of air in syringe A minus the final volume, all this divided by initial volume, then times 100%. Some sample results for a similar experiment that was performed are as follows. Initial volume of the air in syringe A was 7.5 centimeters cubed, and the final volume of air in the gas jar, in syringe A was 6.0 centimeters cubed. So using the formula I stated above, we shall take the initial, which is 7.5, minus 6.0 divided by 7.5, all that times 100, which is going to give us 20%. Now, there are some points to note in this experiment. Number 1 is the apparatus are allowed to cool before taking the final reading because gases expand when heated. Also, the air is passed repeatedly over heated copper to ensure that all the oxygen is used up. Also, the air is passed slowly over heated copper to allow enough time of contact between the reactants to ensure that all oxygen is used up. Now, the glass wool plug. You can see the glass wool plug placed at the end of the combustion tube is used to stop copper turnings from being sucked into the syringes. Something else to note is that excess copper turnings are used to ensure that all the oxygen reacts. Now, in this experiment as in all experiments, there are some errors. So some of the sources of errors in this experiment are: the air initially in the combustion tube is not accounted for. Copper may not react with all the oxygen in the syringe. There is possible leakage of air in the syringes. Knowing that air can leak through the smallest, tiniest pores, there could be some leakage of air through the syringes. Then also there would be an error as a result of wrong reading of volumes from the apparatus. So such errors make it impossible for us to get a 20.9% by volume of oxygen as expected. Now note that if copper tannings are replaced with magnesium shavings, the percentage of the active part of air obtained is extraordinary. It will be extraordinarily high. This is because magnesium is more reactive than copper. Now the reaction is highly exothermic. It generates enough heat for magnesium to react with both oxygen and nitrogen. This reduces the volume of the air left. So that is the end of our lesson. Please continue sharing, comment, subscribe, and like. See you in the next lesson.